Astra 1G will become the 7th member of a constellation of co-located satellites, the first 5 of which consist of Astra 1A, launched on December 11, 1988, Astra 1B, launched March 2, 1991, Astra 1C, launched May 12, Astra 1D.
Anders entwickelt, als ich erwartet hatte. Hättest du Lust, mir Gesellschaft zu leisten bei einer Spritztour nach New York?
Spritztour?
Ja, wir sprechen noch darüber, Elliot.
Nachrichten wieder zu Hause bist. Was weißt du von Ernst Verdoving? Flitzlampjes.
Was?
Blitzbirnen. Ernst Verdoving ist Holländer.
Das weiß ich, Miles. Ich weiß auch, dass er jede Menge Fernsehstationen und Zeitungen besitzt. Aber ich weiß nicht, was ein solcher Mann von uns will.
Ich finde, dieses Holländisch ist eine gutturale Sprache. Elastikje. Gummiband.
Komm schon, Miles. Sag mir lieber, was du vorhast.
Schön, Sie wiederzusehen, Miles.
Ik vond het fijn om u weer te zien, Herr.
Longitude following injection into geosynchronous orbit. Astra will be launched in a stowed configuration and deploy its communications reflectors, telemetry, and command antenna and solar panels following separation from the launch vehicle. Once on orbit, Astra 1G will uplink television and radio channels from several cities in Europe and broadcast the signals back to cable networks, blocks of apartments, and individual homes across Europe. During this morning's launch, the first 3 stages of the Proton will follow a standard ascent trajectory to place the 4th stage and the Astra 1G spacecraft into a circular parking orbit inclined at 51.6 degrees to the equator. Once in parking orbit, Astra will be propelled to its transfer orbit by the Block DM upper stage. The targeted parameters of the transfer orbit include a perigee altitude of 10,290 kilometers, an apogee altitude of 36,000 kilometers, and an inclination of 12.4 degrees. Once in transfer orbit, the Astra 1G spacecraft will separate from the Block DM at a mission elapsed time of 6 hours, 40 minutes, and 32 seconds. Astra will then deploy its antenna and solar arrays and conduct checkout operations for several days before igniting its own onboard liquid apogee engine to place the satellite into its final geosynchronous orbit. Just a few moments ago, the Astra 1G spacecraft manager signaled Astra's readiness for launch. The Proton's first 3 stages have also already given their OK to launch, and at T-minus 1 minute and 53 seconds, the Block DM upper stage will give the final go for launch. The engine start command will be given by the automatic sequencer at T-minus 2.5 seconds. Let's listen for announcements from the firing room as we enter the final moments before launch. This is Proton launch control at T-minus 2 minutes and counting. Launch control confirms that everything is go for the Astra 1G launch at T-minus 1 minute and 30 seconds. T-minus 45 seconds and counting. T-minus 30 seconds and counting. Twenty seconds. 15 seconds. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. We have liftoff of the fourth commercial Proton, carrying the Astra 1G spacecraft on its way to geosynchronous orbit. The Proton has just completed its roll maneuver to align the flight direction. T plus 30 seconds, velocity is 134 meters per second. Height is 2 kilometers. T plus 45 seconds, everything looks good. Coming up on max Q. Mark, max Q, maximum dynamic pressure on the launch vehicle. Velocity is 467 meters per second. Altitude is 12 kilometers. The vehicle is now moving at Mach 1.6. One minute, 30 seconds into the flight, and everything still looks good. We're coming up on the separation of stage 1. That will occur at 2 minutes, 6 seconds into the flight. Mark, first stage shutdown, second stage ignition. Everything still looks good. We have 4 good engines on the second stage. Two minutes, 30 seconds into the flight, the vehicle is now moving at 1,798 meters per second at an altitude of 60 kilometers. Everything is still go. Three minutes and 10 seconds into the flight. Everything is still go.
программе.
220 seconds into the flight, the vehicle is now moving at 2,451 meters per second. Launch control reports that flight control is operating normally. The trajectory looks good. Flight control reports the combustion chamber pressure on the engines is good. Vehicle trajectory looks good.
Значит, прием информации на 300 секунд. Тангаж, рыскание, вращение в норме.
300 seconds. The vehicle is now moving at 3,606 meters per second at an altitude of 128.5 kilometers. All systems good.
320 секунд. Стабилизация ракеты носителя устойчивая.
We're shortly coming up on the separation of stage 2 and the ignition of stage 3 at 335 seconds.
330 секунд. Траектория в норме.
Trajectory is normal.
Есть подключение двигателя второй ступени. Прошло отделение второй ступени. Есть запуск двигателя третьей ступени.
We just had confirmation of a good second stage separation.
350 секунд.
We have a good burn on the engine of the third stage.
360 секунд. Измерительный комплекс космодрома ведет прием и обработку информации. 370 секунд. Полет проходит по программе.
.390 seconds into the flight, the vehicle is now moving at 4,703 meters per second at an altitude of 178.5 kilometers.
430 секунд. Система управления функционирует нормально. 410 секунд. Стабилизация ракеты носителя устойчивая.
420 seconds, the vehicle is now moving 4,491 meters per second at an altitude of 192 kilometers.
430 секунд. Траектория близка к расчетной. 440 секунд. Давление камеры сгорания двигателя в норме.
440 seconds and engine combustion chamber pressure is good.
450 секунд. Тангаж, рыскание, вращение в норме. 460 секунд. Измерительный комплекс космодрома ведет прием и обработку информации. 470 секунд. Траектория близка к
470 seconds, the vehicle is now moving 5,568 meters per second at an altitude of 209.6 kilometers.
490 секунд. Полет проходит по программе.
490 seconds and the flight control program
500 секунд.
remains stable.
Носитель устойчивый. 510 секунд. Траектория в норме.
510 seconds, vehicle is reported normal, velocity 6,139 meters per second, altitude is 219.9 kilometers.
530 секунд. Тангаж, рыскание, вращение в норме.
530 seconds, everything remains go. At 570 seconds, we'll be coming up on shutdown of the main engine of stage 3. .550, everything is still go. We're waiting now for word of third stage shutdown. We've just received confirmation that the third stage engine has shut down. Third stage is separated. The fourth stage and the Astra 1G spacecraft are now in orbit at an altitude of approximately 200 kilometers. The velocity is 7,455 meters per second. Altitude of 222.2 kilometers. In a few more seconds, we should receive confirmation that the aerodynamic shroud around the block DM has separated. Now that we've received confirmation that the fourth stage of the Proton, carrying the Astra 1G spacecraft, has successfully separated from the third stage in parking orbit, we're going to be ending our broadcast in just a few minutes. But before we do, I want to describe to you some of the upcoming events in this mission. About an hour from now, the small rocket motors of the Block DM's attitude control system will begin a 5-minute burn to settle the propellants in the stage's tanks. At the end of the settling burn, the main engine will ignite and then operate for 398 seconds, and the first of 2 firings of that engine that will occur during this mission. 5 hours and 5 minutes later, the main engine will ignite again, this time for 134 seconds, in order to complete the task of placing the Astra 1G spacecraft into its target geosynchronous transfer orbit. Spacecraft separation and the completion of the Proton's commercial mission will occur 16 minutes later at L plus 6 hours, 40 minutes, and 32 seconds. A lot of people were responsible for making the launch we've seen this morning and the subsequent orbital operations as successful as they have been so far. I would like to take the time to congratulate the members of the ILS launch team here at Baikonour for their expertise and dedication. I would particularly like to congratulate the members of the Russian Strategic Rocket Forces and the employees of Khrushchev Center, RSC Energia, Lockheed Martin Corporation, Hughes Space and Communications, and Saab Ericsson for their hard work and cooperation in carrying out this mission. Finally, I would like to thank SES, the Société Européenne des Satellites, for their vision in selecting the Proton to launch Astra 1G and the upcoming Astra 2A. Again, this is Eric Larson from the Baikonour Cosmodrome in Kazakhstan. This concludes our launch broadcast. Have a good morning.
hinter ihrem Bildschirm aus, damit sie ihre Lieblingsprogramme empfangen können und eine perfekte Übertragung gewährleisten.